I have a couple like minor little updates that I'll share now. So one thing is definitely check out the Slack channel if you can. So I know that I've added some new info into the Slack channel, just like some videos, those sort of things. Those will also be linked to in the class notes. And if you didn't get a chance, I would definitely recommend checking out the class notes because, let's see, where did that go? So this is sort of like what Lee and I are going to use as sort of the canonical place to stick everything for each of our classes. So I've added some notes from last class, just based on some questions people had or some things we discussed. If you're interested in more, we can definitely add more as well. So obviously, like, part of this class is just like, we have an hour and a half together, but then if you're interested in learning more, I have tons of videos and other things that are available to you as well. One thing I want to note is I just made this week I made a new channel in Slack called Papers. This just links to popular, like essentially mostly StyleGAN papers. I added this because one, I've been doing a lot of research for this class, and I thought some people might be interested in just sort of reading like where this stuff originates from, some of the research behind this. I'm sort of giving you the diluted version of a lot of these papers, and in fact, some of these papers I like parse about half of it at most. But if you are interested in sort of the raw documentation, this exists, and you should feel free to read it. If you have questions, I can do my best to try to answer stuff, but it's kind of helpful to sort of see how data scientists and other folks think about this stuff. So just something to be aware of, obviously like no requirement for people to check out these channels, but they are there if you're interested. Okay, so I think this week we're gonna get started just sort of talking about some, I'll find my slides here. There they are. So this week we are just going to mostly look at training. So I posted a video last night. I don't expect everyone to be able to have watched it already, but it's basically going to go over the process of training. So we'll go through a bunch of different steps in our work today. So we'll look a little bit at training. Lee is going to go over some things you should keep an eye on while you're training and potential like pitfalls you might run into. So the next couple weeks will be manipulation of models. So we're going to look at just basic interpolation. We'll probably look at how to do projection and a couple other things using sort of the basic StyleGAN repo. So we can look at sort of how to take your model and start making images and videos with it. After that, we'll look at some advanced techniques and we'll sort of figure out a schedule more going forward after that. Thanks, Bug. All right. So I'm interested if anyone has any thoughts on how things went so far. Do you have questions? Did anyone have any problems getting set up? As my cat walks across the screen. Yeah, go for it, Martin.
Yeah, I was wondering about GCP. If you say, are the credits for essentially wall time or the GPU credits? Like, so if you do run something that's not, so say you're doing the stuff like just stuff with dataset tools, is that is that priced differently or is that the same?
Yeah, that's a great question. So if you're running it on the servers, like basically when you set up a server, as soon as your server is running, it's charging you for it. So it doesn't really matter if you're running dataset tools, which only relies on the CPU, or if you're running GPU functions. As long as you're running that server, it's charging you for it. And that actually brings me to a great point, which I think, let me quickly just show you if I can log in. Actually, maybe after the break, we'll do this. I'll sort of show you some things I've sort of noticed about where you can check to find how much money you've spent already using Google Cloud, as well as just sort of like, I actually recorded a part of the video that I ended up deleting, which was just like, I had an error and I went through some logs to try to figure out what was going on, and it ended up being a GCP problem and not a problem with my stuff. So maybe after the break, I can sort of show a couple little things about using Google Cloud. But that's a great question. Yeah, Google Cloud just charges you as soon as your machine is running, regardless of what you're doing on it. Adam, I know you had a couple of issues getting Anaconda set up. I'm interested, did anyone else run into Anaconda issues? Okay, cool. So Adam, you and I can talk like afterward to try to get you finished and set up there. You know, with all these machines, there's always like little nuance issues that can happen and arise. So if you do have issues getting set up on GCP, like please just let me or Leah know. We're happy to help diagnose sort of what's going on there and try to figure out what we can do to get you set up. Hopefully, like I would say, by the end of this week, you should definitely be set up. So if you haven't run through the GCP stuff yet, please do so as soon as possible. Just because like we're going to start getting into training, we're going to start getting into using these tools. So if you don't have an opportunity to actually like get set up and start training your stuff, you're going to be a little bit behind. So I want to make sure that you can do that. And also like, I know some folks maybe like now isn't the best time to even be doing this stuff. So I would recommend just trying to get at least GCP set up. And then if you're into issues, like you can always let Lee and I know, and we can always help you afterward or whenever you are ready to get going. So my next question is, after seeing sort of all the inspiration work and everything, what are people interested in making? Does anyone want to talk about their projects that they have in their mind right now? Or anything they saw like last week that sort of inspired them to try to work on something? Emily, go ahead.
I was really inspired by the idea of using frames from videos as training data. And one idea I've had is to do a kind of like machine learning, like Zoom diary of like people I've talked to throughout the day, or just do like short recordings from different Zoom things and have those kind of like blend together.
Cool, that's interesting. Yeah, I like that idea. You're kind of doing something similar, right? It's like not the same thing, but you're doing something with video as well.
Yeah, so I'm taking some stills from some videos as well, and it's just different outfits and it's the same person, but it's like in all different outfits on a white background. And then, yeah, I've already done a little bit of training. It looks pretty cool, but it looks a little bit too alien now. I'm looking forward to training it for a bit longer and making it a bit more human-like, which would be nice.
Yeah, I think what's cool about both those ideas is that, so we'll talk about this a little bit later as we took through some of the training parameters, but what's good about those is that I try to think about the training set as an onion skin, where it's like if you layer the images over top of each other and were to like do like a multiply filter or something, they would really line up really closely. And Kainen's work does that, and I think Emily, if we were Zoom, it would also do the same thing. So I think it's like that; those are really easy data sets to work with because of that onion skinning effect. We'll talk a little bit more about if you have a data set that's more noisy, like what are some things you can do with that. But both of those are really good examples of places where like the data set will be pretty easy and like well set up for that.
Yeah, I'd also be interested in adding in some noise as well, like maybe with like at a later stage, like adding in some, because it's going to be the white background, maybe it's a little bit too much white, like to add in a bit of chaos or something a bit later, which would be cool.
Yeah, definitely. I mean, that's also like a way to think about it is also you could think about doing that post-process, right? So you could also train it. One of the things you'll learn is like adding noise into these machines is like, we're not really sure if it trains better or worse. My guess is that it trains worse. So when you throw in noise, that can sometimes like mess with stuff. So you might want to think about like, should you do two trainings? Should you do one that is all noise or like all noisiness, and another that is your clean data set, and like mix those two together sort of post-process. There's ways to think about that as well. But yeah, that's one of those things that I think, you know, we're still trying to sort of figure out like what's the best way to actually set up the training parameters and everything for that. Yeah, Adam, go for it.
Yeah, I started playing with, I was mentioning I was interested in the collab or the projection, and you gave me that Google Colab. And I got that to actually work with one of my pickle files. And so I was kind of interested in like the idea of these models being tools or not for creativity and stuff. I've heard people say that, but every time I've done a big, like generated a whole bunch of images, I've never actually found images that I found were inspirational. But what I found was interesting was using the projection was the first time when I gave it an image that it gave variations that I could see as beginning to be something that's like inspirational, because it's not an exact copy. It's like something similar. So I did like just some, like difficult to see, but like, okay, so there is like a famous chair. you're not gonna be able to see it very well, but the result is like a very similar version, but not exact.
Mm-hmm.
And this is the one I like the most, which is obviously taking the Eames Lounger. But what I got is like a way more comfy looking Eames chair.
Mm-hmm.
And it just seemed like something like previously it always felt like the idea of getting inspiration seemed like more hypothetical, and maybe like that all the stuff I was able to generate with that same model previously was really ugly and abstract. But projection seems like a neat way to be able to do, I don't know, like almost like a Google image search, but for like, you know, when you do sometimes in stock photos, it's like, look for something that's similar. It felt like a way to do something like that. So I don't know if that's what I'll do at the end, but I just found that like really interesting and stuff. And I was, I don't know if you guys want, you should probably do your faces too, because it's super weird. So like this one, for instance, thinks my toque is my hair. And so it grows the guy's hair like that. And then I just got really obsessed. This one's really creepy. The result is like some zombie person. And yeah, this one's really weird. And I think my favorite one was this one, but the guy at the end is way better looking than me. So it's super funny to see that it's like, and that was using the existing model that is part of that. And then the other one was using that. So it made me start to think about even a bunch of the existing models I've done before, and now thinking about projection and ways to use it. So yeah.
Yeah, that's awesome. And we'll talk about projection a little bit more next week, because there's even things we could do to even tweak it more. So I know, like, I think it defaults to like 1,000 iterations, where it tries to like, as it's like flicking through all those scenes, it's trying to find the closest approximation. You can make that shorter or longer. And the shorter you make it, the more you're going to get things that are really less close to that. And the longer you make it, the more it's going to really fine tune in on that like nearest neighbor possibility. So if you remember, I think I showed the Mario example last week, and that one lasted for a while. It was like 30, 40 seconds. And that's because they cranked up those iterations to go really, really deep into the closest position. So we can play with that a little bit more next week and sort of see how close we can get to the exact image, or like something really close to approximately exact. So yeah, I think that's a really cool example of playing with that. Yeah, awesome.
Cool. So is projections in Runway now? Is that what I heard, or is this a StyleGAN feature?
Yeah, sorry. So Moises is in my Runway class as well. And someone did add the projection model into Runway. So basically you can do a projection of your face into the FFHQ model in Runway. We'll look at it in Colab, because we'll be able to tweak some parameters a little bit more easily next week in Colab. Stuff like tweaking its iterations and other things. The other thing that's nice is that the Colab version will give you that animation that Adam was showing, which is like actually animating toward it, whereas the Runway version will just give you the closest approximation that it determines. But yeah, there are some examples if you're like a little burnt out on code and that sort of thing. And if you haven't checked out Runway, you definitely should. I have some videos on my YouTube already about how to use Runway. So if you are interested in using Runway, it's a little expensive. I mean, it's expensive-ish, but it's like you get $10 for free to start with. So if you want to play with that, you're welcome to, and I'm happy to send over links if you're interested. I think this class will give you more ability to tweak all these things and really like fine tune into the details you want. But the other options are available as like quick, get stuff set up really quickly and just run it and see what happens. Caitlin, yeah, go ahead, Caitlin.
I like the idea of taking the output of one of these processes and using it to act as the source material for like a total different process. And one thing I'm interested in doing is training a model on hands. I think because pose detection is kind of like a common machine learning task. There will be a lot of good data sources out there, but I figured if I produced some kind of latent space video of generated hands, it would produce some kind of like grotesque thing that I would then be able to run hopefully a 3D pose detection, but even like a 2D hand pose detection model on, and then use that to rig a real model or puppet a different video, I think that would get really weird really fast.
Yeah, that reminds me. So I'm making some notes in the chat just for myself to show. So Kisha Yuma, who is an artist I've talked about before, has a really interesting model where he does sort of like, it's video and he does some stuff with his hands and then he brings it into StyleGAN and it produces some really interesting, weird stuff. So that's one option, is like you could just do a video. But you're right, there are a ton of hand data sets. The other example that reminds me of is, I think, Golan Levin.
Yeah.
Yeah. Okay. Awesome. So Golan Levin did some really interesting stuff with hands, maybe a couple years ago, and I think it was using like a Pix-to-Pix model or something, where it was basically like he was able to detect poses and he was able to add fingers and other things. So there's really some really interesting work there. So I'll add those in the class notes for this week in case anyone else is interested. Will, I think you had your hand up.
Yeah, I'm also interested in both the projection stuff and some sort of puppeteering. So I want to see if it's possible to use video to puppeteer the projection. So take snapshots of some frames, find the projection of each of those frames, interpolate between them. To get something that mimics the original video but is in this projection space. I'd be super, I think that might be a big enough project for me to bite off, but I'm ultimately interested in then taking that, and you showed us that new research that used sort of principal components analysis to get sliders on the latent space. And I'm interested in like giving that to people to like mess with sliders on their face to create an idealized version of themselves, and then using that difference vector in a puppeteered video to like turn that video into that, and then send that farther in the direction of their ideal self. I have no idea whether something like that will work, but that's something I'd like to play with.
Yeah, that sounds cool. I added a note in here for myself to link to there's a new model in Runway, or there's a new model that got released maybe a month ago that's called first order motion, which is basically like you can do your own face tracking or face posing, and it matches it up to another face, and it basically allows you to puppeteer that face. It's pretty interesting. I've seen a lot of people play with it, but I think the idea of taking a StyleGAN model and bringing that in is also really interesting. I have seen maybe a person or two sort of mess with like the very like the very latent edges of StyleGAN spaces and being able to play with that within first order motion. So it may be worthwhile to check that out, and maybe you can link those two up together or just do it. I mean, the problem with a lot of this stuff is real time is very hard, but you can always create sort of like basic examples, and then like, or maybe you like, you interview some people and like have them play with it, and then you learn from how they're playing with it and then make a video based on that. Yeah. Moises, yep.
Hey, yeah, we were speaking about doing sound, reactive sound. I think that's in the syllabus, so I'm curious in what ways. I actually posted on Inspiration somehow a demo that Kyle McDonald did where the mouth was moving up and down, or was like interpolating, but I guess specifically that vector. So I guess it would be those two ways. It's like just interpolating in general, and like I guess isolating a specific thing like eyes blinking, or I also saw Mario Kingelman doing something with like mouths opening and this like lip syncing idea.
Yeah, so there's a couple different ways you could do that. One is looking at, I think I also linked to Robert Luxemburg, who is an artist that also did something similar to that maybe a couple months ago. And his technique was basically like he found a cappella like versions of tracks, and it's just basically, I think it's like a volume detection. So it just detects as people are talking, and then it takes that feature vector that is the mouth opening and plays with that. So we'll definitely look at a little bit of sound stuff, basically like maybe just a basic example like that. And then I think in terms of the feature vector stuff, we'll definitely look at that in the last week or two as well. The thing about feature vectors is if you just want to use face feature vectors, someone else has already done all of the hard work to find what it takes to like rotate someone's face or to open their mouth or to open their eyes. If you want to do that on your own models, it is pretty annoying and lots of hard work. I'm happy to link to that, but we might not have time to get to that exact detail. But if you are interested in just sort of understand the technique of how feature vectors work, we can look at some of that stuff as well. Nabila, is your hand up? Okay, cool. Yeah, go for it. You are muted.
Oh, hi. I want to make a project with selfies. And I know that on Instagram, there's a lot of, well, pictures where I can like make a data set. Do you think that like the pictures are very like low resolution, like if they are like 200 kilobytes, but they are like selfies. So I don't know, like if you know anyone that made something like that, or that I can make, and I don't know, like have an inspiration about like.
No, yeah, I think that would be really cool because I think, again, it's sort of similar to Kynan and Emily's example where it's like, it is still faces, but it's like a subset of faces. And I think in terms of resolution, I think you'll be fine because I think Instagram does like 1080p for their image uploads, which is plenty for StyleGAN. So StyleGAN takes about 1024 by 1024. So I think you'll be fine with that sort of as the resolution. And we'll talk a little bit more about that today, about how to figure out what resolution you should train at. But I think that'd be a really cool example because I bet you would get drastically different results compared to like portraits, which are like, you know, directly on faces, versus what I think is sort of the selfie, which is like the camera's a little bit higher up, or like you're doing like, yeah, exactly, some nice poses or whatever it is. So I think it'd be pretty cool to actually see that. I'd love to see that, yeah. Cool, okay, so I wanna jump into today's lecture just to sort of like run us through things. Again, there will always, like, I'll stick around at the end of class to like talk about more if you have more questions or other things, or have more ideas after seeing some of this work. I'm gonna go through the first part of this, and then I think Leah's gonna take over at some point. We'll definitely do a break. I'll find a good point for us to break for about 5 minutes to go do bathroom and coffee and whatnot, so. Okay, so this week we're gonna look at entirely about training. Yeah, go for it.
Just to interrupt, do you want to share your screen, or you're not sharing your screen?
Oh, I'm not sharing my screen. Okay, well let's fix that. Thank you. I'm in presentation mode, so I just assumed, you know, that's clearly how it's working. Okay, so training your model, that's what we're gonna look at today. Most of what we're gonna look at are the various parameters within training your model. So for a lot of you, most of the defaults will be fine, especially for folks working on faces. Like basically the way that StyleGAN is set up to work with faces. But if you're interested in sort of some weirder stuff or some more edge stuff, or if you've already trained your own StyleGAN models and you just want to learn more and maybe learn a little bit more about some of the deeper parameters available to you, we'll touch on everything within training today. And also I should say, if like a lot of this stuff gets maybe a little bit deep into the weeds of how machine learning works, especially deep learning. So if you're not as familiar with deep learning and you want to learn more, just let me know, because there's some really good video series out there that are like pretty short and pretty like easy to sort of grasp just the basics of machine learning. And if you learn the basics of deep learning, some of these parameters will maybe make a little bit more sense to you. I'll try to talk about them, but if you're not familiar with them, just let me know and I can also dive in a little bit more with them. So really quickly, the steps you're going to follow to train your own model are essentially, you're going to upload your data set to GCP. I recommend using GDown, which is just a little pip library or a Python library that allows you to download files directly from Google Drive. So a video that covers all that material, but that's my recommended way. It's way faster than having to try to upload directly to GCP from your laptop. You're going to take that data set, you're going to convert it into what we call TF records. That's basically just a data format that StyleGAN prefers. It just makes a file called .tf records, and then it can read that into the StyleGAN library. You're then going to run the training command, which we'll talk a lot about today. And then I recommend that once you're running, so training on on GCP takes a couple days, just because of the small number of GPUs. And then if you use the P100, it's a little bit slower than other machines. So basically you'll want to check every once in a while, just to make sure your machine is running. I have in the video that I'm going to show you, like I've got some examples of how to check to make sure it's still running, check to make sure your images are producing like results you would expect to see. I generally check every like 6 to 12 hours. So usually I'll check in the morning and I'll check again in the evening, and I might check once during the middle of the day just to make sure it's still running. You know, with GCP, you get $300 in credits. So in that case, if a machine isn't running for a couple hours, it's not the end of the world. But if it's running for a day without you noticing, like that can be just annoying more than anything else. So you definitely want to check every once in a while, and the ways to do that are just like logging into your SSH, and I've got some commands that show you how to check to make sure your models are still running, and then ways to like CD into your folders to just check to make sure that you still have, it's still producing fakes that are interesting. So there's 2 videos that you should look at this week if you're interested. The first is training in Colab. So again, I don't necessarily recommend training in Colab, but if you want to do stuff on the super cheap, or even after you're done with GCP credits, you might want to try Colab because it will essentially be free. But it's a little annoying because you have to restart your machine every like 12 hours or so. So there's a video here. I should note that this video is mostly built around my fork, which is like the basic NVIDIA model. But if you want to do other stuff, it's fairly easy to make changes to it to work with it for like so many other forks that we're going to work on this week. Second video is training in GCP. So this is the video that I made last night. It basically covers all of the things you need to do to get set up on GCP and start training. So this is basically the video that you'll want to watch for this week, just to sort of understand all the steps you need to do, how it works, and then I give some additional stuff on how to check your machine and other things. So this is definitely the one to watch out of the 2 of them. The Colab one is there if you're really interested in it, however. So most of today we're going to talk about the training parameters, and I should also mention we're going to use the Skyflynil fork for this whole session. The reason we're going to do that is that this one supports non-square images. So if you've taken my previous StyleGAN class, you know I sort of told you like, hey, just work with squares. For this class, I think you're open to working with non-square images, but there's still some caveats with that, so you still want to keep an eye on that. And we'll talk about what those caveats are and how to work around different sort of restrictions on what you can do that is non-square. So just know that if you try to run this in either the traditional NVIDIA fork or the traditional NVIDIA repro or my fork, some of these training arguments don't work. So you'll definitely want to run this in the Skyflynil fork if you're interested in some of these parameters. So I'm going to start with just like what's required. Every time you run a training command, these are the required parameters. And then I'll talk about some of the optional parameters and other things. So when you run a command, when you run the run_training.py file, there's 3 things you have to provide. The first thing you have to provide is a dataset directory. You have to provide the dataset folder name, and then you have to provide a config. So let me just go, I'm going to go through each of these one by one and just sort of explain what it is. So the dataset directory is, this needs to point to the parent directory holding all of your TF records files. So this is, for most of you, if you follow along directly with me, this will be /datasets. Now this is paired with the dataset argument, and this points to the direct parent directory that is holding your TF records files. So the way I think about this is that the dataset _dir plus dataset equals the path to your TF records files. That's all you really need to think about, but because StyleGAN breaks them up into 2 different arguments, you have to sort of think about how you separate them. And again, I would say like, if you are just following along with my example, the video that I put up, it'll be pretty straightforward and you won't really change much, except you'll change the dataset command to be whatever the folder name is for you. And lastly, the thing that is required is the config. So StyleGAN2 has options of different configurations you'll want to use. And most people are often asking me about this, like what do the configurations mean? So the configurations, and this comes directly from the StyleGAN2 paper, is you'll see the configurations here. So they go A through F. Now, to be honest with you, most of you will just work with either F or E, but I can talk a little bit about just like what happens here. So A is basically StyleGAN1. So if you remember the StyleGAN1 that we sort of looked at, it has a little bit of blobby. It's not as great for certain types of data sets. That's what config A is. B through D are basic changes that they have made to remove some of those blobs. That's what weight demodulation does. Added a couple other things to just sort of like improve the network overall. So network or configuration E is where they actually remove the progressive growing. So E is actually where they found that they get the best results. And then F is where they added in additional stuff to make it work with bigger data sets, or not bigger data sets, bigger resolution images. So you'll see on the right here, this is sort of the, this is how often it trains at 256, 512, and 1024. This is config E. So you'll see it mostly focuses around the 512 area, whereas config F focuses around the 1024 by 1024 area. So my TLDR here is that essentially you want to use config A if you just want to get StyleGAN1. I don't really recommend that, but if you want to play with it or you like the look of the noisier, blobbier StyleGAN models, you can do that. You can basically use StyleGAN1 in StyleGAN2 by using config A. For everyone else, I recommend using either config A for something, or config E for something around 512, or config F for something larger. So my guess is that most of us will just use config F, and that's totally fine. If you have like a smaller size, like a smaller resolution data set, you can use config E. But even if you use config F at that point, it'll probably be fine. So this is like my TLDR for configs. Don't worry about any more of it. If you are interested in learning more, I definitely recommend reading the StyleGAN2 paper because it goes into detail about what each of these does. But for most of us, the F or E config is totally fine. Okay, so here is a list of the many, many optional parameters that are available within the Skyflynil fork. So no matter what, you have to define these three things in every time you run the command. But almost everyone adds in a couple additional optional parameters. And I'll go again through these one by one, starting with the result directory. So result dir is, actually, one thing I'm realizing right now, this says underscore, but let me double check. This might actually be a dash. I want to say StyleGAN2 uses dashes, but anyway, that's a little aside. The result dir is where you want your results to go. The default is /results, and that's just going to dump everything into a results folder. Now, this is important because if you want to do this on like Colab, you might actually want to write these results to something like your Google Drive folder. So that way things get saved to Google Drive rather than being saved in Colab and then you like lose all those files in Colab. This is more important for Colab. I would say for most of us, if we're training in GCP, leaving this to the default /results is totally fine. Number of GPUs. So if you're using multiple GPUs on GCP, you can edit this. Basically, you just pass in a integer value. So it's going to default to 1. But if you have more than 1, you can say 2 or 4. Number of GPUs, I think StyleGAN can only do like logs of 2. So it's got to be 1, 2, 4, or 8. So just be aware of that. Most of you won't have to worry about this, so I wouldn't worry about it. But it's available to you if you want to. You have to use this if you want to use multiple GPUs, however. So total K images. So StyleGAN, unlike other models, doesn't have a concept of epochs. So epochs are usually, say my training data set is 1,400 images. An epoch is how long it runs through all of those 1,400 images. StyleGAN doesn't really think about that, in part because if you haven't, in the case of like having 65,000 images, an epoch would last forever. So StyleGAN actually uses a concept of K images, which is how many passes it do through 1,000 images. So in the case of like the default, I think the default for this is 20,000. So it's actually, I don't know, 20,000 times 1,000. What is that? 20 million? Is that right? Did I do my math right? I don't know. Anyway, so basically, they don't think about epochs, they think about K images. And the K images is important to think about because that's essentially how long it's training for. Now, the truth is, if I set this to 20,000 K images, I honestly very rarely actually run it for that long. I usually stop it at some point before then. So as long as you set this number pretty high, you'll be fine. I wouldn't really like worry about it too much beyond that. 15,000, 20,000, those are good numbers. It's just basically if you want to be totally lazy and just like never look at your machine again and assume it works perfectly, you can just set it and let it run for a month. But for most of us, we're going to be like, we're going to want to watch that water boil and like check on stuff pretty frequently. So as long as you set this is high, you'll be fine. Okay, so the next parameter in here is what's called gamma. I have to be honest with you, before this week, I hadn't really looked into gamma or even played with it. So I asked around with some people that I know in the StyleGAN community. And essentially what Gamma does is it helps sort of with like some regularization. So again, I don't know how much you're aware of deep learning and how it works, but if you know what gradients are, or like a gradient descent, essentially the gradients in these models can be very noisy. And what Gamma does, it helps out smooth out those gradients. So the default for this is 10. And the StyleGAN, the people who made StyleGAN2 said that 10 worked on most of their models, but they had a model called Houses, or yeah, I think it was Houses, that was a little messy. And just in terms of the data set, it was noisy, lots of different angles, lots of different like crops, that sort of thing. So they increased it to 100. And they said that basically like it affected, it like made the model a little bit smoother, but that it also affected sample quality. So it actually affected your outputs. So I think for most of us, like we could probably just start with a default of 10 and it'd be fine. If you do have a particularly like noisy data set, like say you have a bunch of animals and you want to train them together, you might want to increase this a little bit higher. But in general, like I think you'll be fine with the default of this. I've actually like never used it before. I actually think I started using it this week just to sort of see what it would do. And most of my models come out fine. So this is like a very detailed parameter if you're really interested in it. I also linked to some more like responses from people who I think are like pretty smart about this stuff, and they gave me some additional information if you are interested in it. So there are two arguments within StyleGAN2 within the Skyflynil fork for mirror augmentation. So all of the StyleGAN2 models come with mirror, the first one, which is mirror augment, which is a left to right flip. So obviously that makes sense. So basically what a mirror augment does is it allows you to add to your data set by flipping images. So one way to create more data for your machine is to flip images left, right, top, bottom. Left, right makes sense when you have a face, which is like sort of similar, like, you know, somewhat symmetrical across this, but maybe a little different, right? No one's face is like perfectly symmetrical. So by flipping it, you get additional data out of that. So all the StyleGAN2 models come with this one. The Skyflynil model added mirror augment V, which is top to bottom. So it would flip this way. So now, again, if you have very abstract images, you could use both of these and it would be fine. If you have, say, faces, you would want to use the top one, but you wouldn't want to use the bottom one because you don't want someone's mouth at the top of their head. You don't want even their eyes switching positions. So it's important to think about what your data set is before you just say true to both of these. If you have questions about these, I'm happy to like take a look at your data set and maybe make recommendations. But this is kind of nice because it does add additional parameters. So especially if you have small data sets, if you're at like 500 or like 750 in terms of images in your data set, you definitely want to think about it if you can run one of these to make that, to augment your data set a little bit more. Okay, so metrics. This is the one that like everyone asks me about, and I have a very like strong stance about metrics. So my TLDR is that you do not need to use metrics on your models. I can get into the details of that in just a minute, but essentially metrics are used for data scientists, right? They want to know how well their data set is performing from like a computational and like literally like quantitative standpoint. You and I are mostly looking at how it produces new images, and that means metrics are not as important to us. And that means like we shouldn't really have to worry about it. Like if we're looking at our fakes, it's going to be good, and like we're going to judge on the eye test. The other reason I don't recommend using metrics is that it can give you a false sense of hope or like insecurity about your model, right? Like I often see people in the Runway channel where they show what's called the FID score, and I see people who are like, my FID score is going up. Does that mean my model is getting worse? And it's like, it might not be. And there's a lot of reasons why FID scores are not good for most models. The other reason I don't think it's helpful is that it actually adds time to your training. So adding something like the FID score, which also isn't even that good of a metric for StyleGAN2 models, can add like 45 minutes to an hour every time it runs. So that can like really quickly weigh down on you if you run it every 4 ticks or every 8 ticks or whatever. So my TLDR is just don't use metrics. If you're interested in learning more about what metrics are available to you, the StyleGAN repo actually has all of these metrics are linked to. And so if you were to pass in the argument metrics and then equals, and then what's here in the left-hand column, is what the metric you would want to call is. So it'd be metrics equals 50, FID 50K or IS 50K. Now you'll see here that they have in this sort of third column here, how long it takes to run those. And those run on V100. So these are actually like faster than I would say are realistic especially if you're using P100. I've actually found the FID 50K takes about 35, 40 minutes every time it runs. So like these are pretty lengthy, right? So like you definitely don't want to run linear separability, which takes 10 hours on a V100. That's going to take like 12 to 15 hours on a normal GCP machine. And while these are helpful scores, it doesn't really help. The other reason why like I don't recommend using a lot of these metrics are mostly built around certain data sets that most data scientists use like pretty frequently. There's one called ImageNet. There's some other models. And so like these are more or less built to like work with those data sets. And your data set is not those data sets. So when you aren't running ImageNet, you are going to get a weird score because it's trying to match it to ImageNet. So I spend a lot of time here because everyone asks me like, how do I use metrics? Why isn't my score good, et cetera, et cetera. And I just want to say like, do not worry about metrics. Like metrics are not a big deal. It is not the end of the world if you don't use them or don't even know how they work, because for us, like we're most interested in the eye test. Go for it, Moises.
Okay, so I just wanted to understand what you mentioned. So metrics are compared to ImageNet, like to results happening there?
Yeah, so one of the things, I don't want to get too deep into this. There's some good papers around like why this doesn't work, but essentially the way these work is that they pull down a pre-trained ImageNet data set, especially in the case of inception score. So it pulls down ImageNet and it tries to compare your StyleGAN results to ImageNet. And ImageNet is like images of cats and dogs and birds and water bottles and other things. So if you're training on a data set that doesn't include those, it's going to say like, these don't look anything like dogs or birds. And it's like, well, yeah, of course not. So again, like an FID is similar, although a little different, but it also uses ImageNet. If you are really interested in running metrics, just sort of see what happens, I actually would recommend the PPL_WEnd. This is a new StyleGAN metric, and it's probably best set up for StyleGAN itself. You can click this link and learn more about it, but in general, I would just say like you don't really need to worry about metrics. Adam, yep, go ahead.
As far as like generating the metrics, is there any issues later on if you wanted to do something else like projection or things like that? Would have you needed to like generate the metrics while training, or is there any disadvantage going forward by not using the metrics later and having access to it later? I don't know if that makes sense.
Yeah, no, there aren't. And also you can run metrics afterward. So there's actually a Python script that is called like run_metrics. So you can actually run the metrics afterward if you want to, if you're interested, just sort of see. Okay. Like you could actually point it at a pickle from early on in the steps and then point it at a pickle for later on the steps and see if your score changed. But yeah, there's no like requirements to run metrics at any point. Cool, okay. So I'm also gonna spend a little bit of time here because this is probably the thing that's gonna be most important to us. So min-h, min-w, and res-log2. So these are the commands that actually tell the data set the resolution of your images. So these three commands have to go together. So if you're gonna use one of them, you're gonna use all of them. And most of the time, I think, unless you're actually running 1024 by 1024, you'll need to use these. So these are like semi-required for this class, I would say. So really quickly, the res-log2 defines, again, it's getting mathy, but the logarithmic scale of, I don't know what poser, of maybe the cat typed that in, but something power of 2. That's what that should say. So 2 to the 7th, so if you'll see res-log2 equals 7, that means we're using 128 pixel blocks. And I have a screen that'll next show you what that means. Res-log2 equals 8 is 256 pixel blocks. So these are the two that I see. You might be able to get away with using 2 to the 6th, but I've never actually seen anyone do that. So here's how this works. Res-log2 equals 8 is 256 blocks. So if I want to do a 1024 by 1024 model, it's min H equals 4, min W equals 4, and you'll see there are 4 blocks. 256 times 4 equals 1024 by 1024. So I've recommended that you look at like 1280 by 768 or 768 by 1280 or 1024 by 1024. And here's why, because the math adds up really easily for these. So I do a lot of my models in 1280 by 768 or 768 by 1280. And here's the math for that essentially. So it's 5 and 3 times 256. It just depends if you want it vertical or horizontal. So vertical works well if you want to post stuff to Instagram. Horizontal works really well if you want to do 16 by 9 type of video. So I think Kynan, you had asked me about this, about like, what do I do with 16 by 9? So with 16 by 9, it doesn't fit into this math. So basically what you have to do is either have to add leaders to the edges, like the black edges to your images, or you have to, there's some things you could do, like you could actually mirror the edges to get like basically it looks full bleed, but it's like at the very edges, it's actually just being mirrored back to you. So the thing is, you do have to, like, you can't upload images that don't match these numbers. They have to match these numbers exactly. And everything in your data set has to match these numbers exactly. So even if one image is not 1024 by 1024 in your 2000 picture data set, it will throw an error. So like, it's really important to keep your numbers consistent here. So I have a library called Dataset Tools, which I think we've linked to in the past, but I have a bunch of videos on that on how to like basically like taking thousands of images at one time and crop them all to the same size. So there's a bunch of resources. If you are interested in those things, if you're interested in like, how do I do reflected edges or how do I do black edges, like that sort of thing, just let me know. And we do have some resources around that, or I can just tell you sort of like how I would approach it. So this is 256. I generally recommend that if you can stay within the 256 range, you do. The reason for that is that this reslog2 equals 8 gives you one layer deeper of a network. And that means the network trains a little bit better. It also is a little bit computationally better because you're not trying to individually compute multiple little blocks. You're only creating like one block or two at a time. So if you do want to do something more fine-grained, you can use reslog2 equals 7, which is 128 pixels. And again, like, so you could actually do 1024 by 1024 in log 7. It just means your min H and min W will be doubled. But you can also get some weird things like 896 by 640. I don't know why you would want to, but you could if you want to. If you say you only have images that are 900 pixels tall or something, you could actually compute to this size. Now, I will say this is going to be hard because we can't do transfer learning off of this. So it'll take a little bit longer because I don't have a model that already exists of this size, whereas in some other cases I do. And we'll talk about transfer learning in just a minute. But it's helpful to know that, like, in general, try to stick to this size, but if you need to get fine-tuned, you can. And we'll talk a little bit about what that might mean for you in a later point. So this is sort of the big thing you need to understand. The other thing I want to make a note of is that I have tried to go bigger than 1280 by 768 and have generally had issues with it, where it's very tricky to go larger than 1280 in terms of dimensions. We can try if you want to, but in my experience, it hasn't gone well. So I've tried to crank it up to, what is it, 15 something, whatever the 768. Oh, everybody back? Did I freeze? I froze, right? Cool, okay. Moise, did you have a question?
Oh, I had a question regarding those edges. If your whole data set has those edges, then your output is going to have those exact edges, or are they going to like be blurred? Like if you do want a ratio that's specific, like in my case, I was trying to think of something for like a VR headset, like Panorama. And I don't mind, you know, I have to deal with the pixelation, et cetera, but just to get that ratio right.
Yeah.
Would that work? Would the edges come out and then you'd get the ratio you'd need?
Yeah, I would say like in my recommendation, it would be something like, I would probably recommend actually just mirroring your edges. Like I would say like, it's probably just better to mirror your edges because it gets a little bit more of the pixels. And then what you would do is once your model is finished, you would recrop it to the size you need. Black borders are fine, but I do find that sometimes the border bleeds a little bit, like it gets blurry, and sometimes it gets blurry in the opposite direction you want it to. So I would just say in general, mirroring might be a better solution. Will had a question that he put in the chat. Will, do you want to go ahead and ask?
Yeah, I was wondering if you'd ever want to go bigger than 256. Like if you've got a 1024 by 1024 image, and do that in one big block instead of 4x4.
You certainly could try it. I've never seen anyone do anything higher than 8. My guess is that if you did a 10 block, you would actually like basically like it would compute the entire image at one time, which is like actually like would be good. But my guess is that would be too computationally intensive and would probably overrun your GPU. So there's sort of like a little bit of a balancing act here of like if you don't have a 48 gigabyte GPU, which like 99.9% of the world doesn't. You will run into computation issues with going bigger than this, which is also what you run into with if you do something higher than 1280, you run into GPU issues. Cool, so now seems like a good time for a break. Why don't we take a 5-minute break, come back at 31, and then we'll wrap up we'll go through a couple more training parameters, and then Leah will talk a little bit about training. So I'll see everybody in 5 minutes. Moises, you want to tell us about this idea you have?
Hello? Yeah.
Yep, go for it.
So,
Yeah.
I've been trying to figure this out because here at the museum, here's my background. We're trying to figure out how to show more art and like especially like spread beyond the museum walls, and like what are the solutions people are doing that are interactive and engaging. And one thing that I partook on Friday was a VR competition that we did over the US. It was 4 artists from different states. And the setup we ended up doing was actually through Zoom. And it was, there's certain things with like Siphon and using like a camera web client. And eventually the Zoom account was live streamed onto another computer. Like the video output was live streamed onto another computer. I mean, the video output was sent to another computer that then did the live stream. Mm-hmm. So I'm just curious in terms of showcasing, engagement, like celebrating, promoting, like all these kinds of like culminations, a way to kind of present. And I'm happy to kind of look more into that because it's something I'm doing already for the museum. And yeah, it seems like I'll get you guys a video of the one I just did for Friday. But maybe there's a way that we can both, like each of us present, and there's still like the active commenting and documentation.
Cool. Yeah, I know Leah and I are both really interested in making sure that everyone that makes work out of this session gets to share it. So Leah and I also have some ideas on how we can make sure we share stuff, but I would definitely say like, if you are making stuff, please make sure you share it at least on social, and like you can tag me in it, and I'm happy to like repost your stuff because I love seeing everyone's work. So, but definitely, I think we can definitely come up with a cool solution for the end of the class to like sort of celebrate everyone making stuff. Anastasia, you had a question that I would love to hear you talk about.
Yes. I mean, I've been trying to work with dataset tools, and Leah knows that I've been having some issues. So I'm resizing my images right now in Photoshop until we figure things out. But if dataset tools kind of resizes it to 124, like I'm not sure what the DPI should be. What's the resolution if you end up doing it by hand?
Yeah, so I mean, I would say like the way, or like machine learning tools don't really think about resolution, or DPI. They think about resolution, but they don't really think about DPI. They just look at pixels. So I would say if it's 72 DPI, I usually just leave it 72 DPI. That works fine. Yeah, but for the most part, like the way that these models actually take in the input is they just look at the individual pixel colors and they don't actually think about like how the pixels are sized in that way.
But do you think the size of the image, because the DPI also affects the size of the image, do you think that will be affecting the larger data set? Like, does it take longer to change something that's bigger in size?
It definitely does take longer, but if it's 1280 versus, if the total pixel count is 1280 versus 1024 versus 512, that will matter. But the actual resolution, the DPI behind the scenes doesn't to the model.
Thanks.
So you can make it 300 DPI, but still have the total pixel count be 512, and it's only going to see 512.
Got it.
Cool. All right, so let me just finish up some of the training parameters, and then we'll jump into sort of some things to keep an eye on when you're training stuff. So there's another sort of group of arguments here. If you're not familiar with that terminology, what that means for deep learning, I can share some results with it. In general, I have found that the learning rate, the default learning rate works fine. So you should feel free to just use that. In this case, you can change the learning rate. And in addition to changing the learning rate overall, you can also change the learning rate just for the generator and just for discriminator. I would say in TLDR, keep your defaults as is, which is 0.003. And keep it as a default unless you see issues. And I'll talk about those issues in a little bit with Leah. But also basically if we see it in your model, I might make a recommendation to, hey, try this or that type of thing. Use raw. So this one's pretty straightforward. If you follow my commands within the GCP video, this is on by default. So this for Skyflynil, this is on by default. Basically all this says is that to use a raw TF records format rather than the computed one, which is like uses a bunch of different files. If you've been in my previous classes where I've taught just like the basic NVIDIA version, you're used to seeing a TF records folder that has like a number of different TF records files. We basically don't use that for this fork. We use raw JPEG or raw pixel values, and that works fine. So you don't really need to worry about this. If you do have some questions about this one, if you're taking a TF records data set from a previous training and you don't want to reformat it, you do want to turn this off, however, I would say. But in general, I'd say just reformat it to work with Skyflynil. It's going to be faster and generally just better overall. There's a flag in here called use attention. And this adds an experimental feature that adds self-attention layers to your architecture. Self-attention is like probably a topic for an entire like course itself, but self-attention, the way I would best describe it is that it helps sort of look at the, so I think actually this describes maybe what Will, you were talking about, which is how do we look at the entire picture at once rather than looking at the individual pixel blocks. Self-attention tries to do some of that work. So basically, I've seen a lot of people say that they use it for when they want to do dogs, or like if you have a data set of dogs or cats with legs and they're like, if you were to just throw that at a regular StyleGAN model, you'll get more textures than you would overall shapes and structures of animals. So self-attention can help with some of that. It also just depends, again, remember how I was talking about that onion skin? If all of your animals are like in the same central location versus having some animal over here, some animal over here, like if they're all like onion skin where they're all sort of the central, like you don't need attention. But if they're kind of all over the map, self-attention might help. If you're interested in using this feature, let me know and we can look at your data set and see if it makes sense. I've just started using this in some of my data sets to see how different it works. But they do know that the person who made this library does note that it's an experimental feature. So I haven't seen anything that crashes. It just might mean your images might not look as good. So I wouldn't say just turn this on by default. Like, let's talk about it if you want to try to use it. And then resume with new nets. This is a very like new sort of feature where it's just basically like, if you start training with attention and then you want to turn attention off, you'll want to say yes to this, or vice versa. It's basically if you're going to change your network architecture, you want to pass this in that says resume with new nets equals true. So just be aware of that. Okay, so that covers all of the parameters you can pass in during the argument of the run training command. There are some editable parameters that you might want to edit directly in the files. So I'll talk about these three, they're basically grouped into 3 groups, and we can talk about them in really quickly. So mini batches. So mini batches are pretty important to deep learning. Basically, you want your mini batches to be as large as possible, but that can be, you can be hampered by the size of your GPU. So most of us are working off a 16 gigabyte GPU card, which means the default, which I believe is 32 for the mini batch size and 4 for the GPU, is pretty much all you can do. You might be able to squeeze out a little bit more, but you probably can't. So I'd say just keep it as a default. If you do have access to a bigger or even smaller GPU, let me know and we might want to tweak these numbers. So I have a 24 gigabyte GPU card and I can double both my batch size and my GPU size. All this really means is your main batch size is how much is computing overall, and then your mini batch GPU is what you're handing to each individual GPU. So this is dependent kind of on your training resolution, GPU size, a bunch of other things. I would say your defaults are probably fine, however. Image snapshot ticks and network snapshot ticks. This is how often you want to output a fake test file and a pickle file. I think this defaults to 1. So basically, every time you have a tick, you output a fake image, and I believe it's 4 for network snapshots. So every tick, which we'll talk about ticks in a minute, every tick is or every 4 ticks you get a pickle file, and we'll talk about that in a minute. But basically, you can edit this to be 1 and 1 if you really want to get like every single pickle file possible, which I don't necessarily recommend because it's really going to kind of blow up your storage space, but you could do it. Or if you want to like actually just make them higher and just say like, I don't really care about getting this stuff too frequently. Oh, okay, here it is. So here are ticks. Basically every tick you get an image, which is the fakes, and the numbers increment based on batch size and a couple other things. So don't be surprised that you can't get 478 and 479. It just doesn't work like that. It's basically what the machine calls a tick. This is set to output probably every single one of them. And then you get a pickle looks like every 2 here. So this is set to 1 for the first number and then 2 for the second. So you could set this to 4 and you would get a pickle every 4 fake images. You could set it to 8, which I do sometimes just because I know I just want to let it train for a while. And you can do that as well. Resume pickle and resume K-image. So these are used to resume from a pickle file. This is basically if you break training or if you have a mode collapse and you want to go backwards, you can reset this manually. It's also really helpful for transfer learning, which we will talk about, I think, next. But essentially, this points to a pickle file that already exists, and you can pick up from that pickle file and start retraining on top of it. Resume K-image basically says, so in the case of like this, say I wanted to pick up from this snapshot file. So it starts, so this is saying it's 10,474 K-images. So if I wanted to, for just math purposes, like also know where I am in the newest training, I would pass in 10,474 for resume K-image. In most cases, this number doesn't matter. All it matters for is that total K-images is when it stops. But sometimes it's helpful just to remember how long you've been training something for. So if you want to edit any of these, the first 2 are in the runtraining.py file, and the last 4 in the training loop file. And you can just do a search for these variables, and you can edit them. So what does transfer learning look like? So transfer learning is kind of a cool little technique that we can use within StyleGAN. And basically transfer learning says, if I've already trained a model on a certain data set, I can then pick up from that data set and retrain on top of it. And the thing is, I sort of describe this as like learning English, right? So if I were to ask you as a human to write me a single sentence in English, and let's say, or I guess maybe let's say like, write me a single sentence in Russian. I don't know, I don't doubt many of you know Russian, but basically the way to learn Russian is you would have to learn a whole bunch of stuff to be able to write 1 sentence in Russian, right? And that's sort of the same thing with how these things learn, is they learn a lot of stuff they shouldn't produce to produce faces, while also learning how to produce faces. So when we say give this now if we give a new data set of dogs, it still knows how to kind of produce dogs, even though it's been trying to produce faces because it's been told what not to produce. So by learning those different sort of pieces, it can very quickly learn new images or new data sets and save you a lot of time. So I find transfer learning saves me 3 to 4 days worth of training time, which if you multiply that times your dollar amount for a GPU rental, that's pretty big. That's like 50, like maybe $100. So that's a very good amount of time to save you. So in most cases, I would say if you can transfer learn, do transfer learn. I've yet to find an example where transfer learning doesn't help and doesn't like interfere. So a lot of people are worried like, oh, well, should I be training this data set of, you know, dogs on a data set of faces? And my answer is yes, because it's going to save you 2 to 3 days. Now, if you know of a data set or a pickle file that is already trained on dogs and you can train on top of it with new dogs, like that might save you 6 to 8 hours of training time versus just any old transfer learning data set that is the same resolution. That might save you 2 to 3 days. So yes, if you have access to other data sets you can transfer from, that's helpful, but it's not the end of the world if you don't. Moises, go ahead.
So one of the things I'm exploring is like graphic design and logo data sets. And I found one, but I think their whole setup is trained on like 32 by 32 pixels. So is that an example of where I should?
So, okay, so one thing to know about transfer learning is you have to pick up from the exact same resolution. So the reason that most of my classes I taught 1024 by 1024 is because we can transfer learn from the FFHQ pickle, which is also 1024 by 1024. If you have a 512 by 512, you can train 512 by 512 on top of that. But if you have 1024, you cannot transfer learn off of a 1024 by 1024. So that's why I recommend if you're going to go non-square to do 1280 by 768 or 768 by 1280, because I already have models you can transfer learn off of. So that's where it gets tricky, where if you have a weird size or shape of your images you want to use, we can, but you'll have to train for a little bit longer. You have to train for the extra 3 or 4 days because it's possible that I don't have a model to train it to transfer learn off of. Esteban, I think you had a question. Yeah.
Yeah. Do you think that it's a good idea to do the transfer learning based on the model that I created before? Do you think that that would be a good idea? By the way, I'm planning to do the like a continuation of the same style that I've been working on. So that's why I'm asking.
Yeah, I think that'd be a good idea. So yes, also if you have your own data sets that you've been training on, you can transfer learn off those. And then if you have a, like, let's say, I don't know, I'm really into dogs today apparently, but if you have a dog model you've already trained and then you want to do a different subset of dog models, you can train off that. And again, it's going to save you 4 to 6 to 8 hours. So it's like, it's helpful for sure. Whereas like the reason that training off of the FFHQ from default is helpful is because this has been trained for 20,000 K images. So the longer you train, the better your resolution is going to be, the more these convolution networks sort of know how they work. So transfer learning off of any of these is going to be better than nothing. So I'd say for you, Esteban, too, yes, you should definitely keep training off of your own networks. I generally am transfer learning off of my own stuff as well. Yeah. Martin.
Does it matter so you talked about K images before, so say the model you want to transfer from has seen 20,000. So if you take the Flickr faces one, it's been trained for 20,000 K images. If you then, does it matter, like should you set K images to be 20,000, or what happens if you set it to like 300? You know, like, I mean, is the learning going to be different?
Yeah, so the way that transfer learning works, and like the truth is, like, honestly, we don't know 100% why transfer learning works. So it's a little bit of a black box about like how exactly it works. Like I'm making the analogy that's like learning, and like you learn stuff you shouldn't do and you learn stuff you should do. We're not entirely sure. So what I would say is, like, if you're going to transfer off anything, transfer off something that has been trained for a while, just because the hope is that it's learned a lot of stuff in there. But you know, the truth is, like, if it's been trained for 10,000 K images, it's probably also going to be fine. And I think your question is, it's been trained for 20. Should I set the K images to 20? Again, this resume K image doesn't actually matter for anything other than when the machine should stop. So that this thing has been trained for 20,000 K images doesn't matter to the model. It used to actually in StyleGAN1 or in config A, where progressive growing was used. It did matter because the K image mattered for the resolution. So if you're going to use config A, it does matter. For StyleGAN2, and that's actually, thank you for reminding me of that. For StyleGAN2, it doesn't matter. But for StyleGAN1, it did matter, yes. So, okay, so here's how transfer learning will sort of look. Your first couple of ticks will be very weird. So this is the very first tick of me training on top of it. And you'll see you've got some like weird things going on with this woman's hair. You've got some weird facial things going on. And then this is probably like 4 or 6 ticks in later. And you'll see like it's starting to obliterate people's faces, but you can still see them. Now this is an example of where some people would stop the model and just train off of this because it's super weird, right? This is what's called mixed model learning, where you have like half learned 2 different models and you get this very weird output. And some people like will just, and we'll look at this actually maybe next week. Some people actually just do this over and over and over again with different models, and you get really weird results because, again, remember that these models are sort of like half trained on some things, and then they're still learning the new thing. So you'll get some weird outputs. You will see weird outputs for your first couple ticks. Don't be shocked or scared if you see that. You're like, this doesn't look like anything like my data set. And that's because of this. So it's one of the bonuses and one of the downsides of transfer learning is that at first you might be like a little worried, but it is totally common and don't worry about it. So while you're training, again, remember it's helpful to just sort of like keep an eye on what your file folders look like. So if you do an LS or just look at what's inside of your results folder, you'll see a number of files here. And I briefly talked about this before, but basically like your pickle files will have these .pkl outputs. These contain the actual model weights or like what's been trained. Do not delete these files, or like do not delete the latest one, or like do not delete the one you like. If you delete these, you cannot generate images off of them. So you have to use these pickle files to generate new images. So make sure you have at least 1 pickle file in your folder at any time, because if you delete it, you will not be able to work off of it. Whereas these fakes are just outputs for you to be able to check on the training. So the fakes are generated, they are basically like, they look like this. These are what a fake file looks like. It's just a grid of images. And it lets you sort of determine like, oh, this isn't trained far enough yet. Maybe it is, like that sort of thing. So this is a way for you to check to see how far along you are in training. You can delete fakes. If you are like, this is clearly not a good fake and I want to free up some space on my machine, you can delete fakes, no problem. But do not delete pickle files. Or like, what I would say is also you could delete, like let's say I really like the output of fake 10491. I wouldn't want to delete this pickle file. I can delete the other ones, but then I can never generate off of that moment in time again, which is probably fine. But just know that like deleting pickle files is a little bit more dangerous than deleting fakes. And then lastly, if you do run metrics, there will be a .txt file that usually says metric and then whatever the metric you're using is, and that will just contain your scores. So your scores will be outputted as you're generating images, but also like they are stored in a .txt file. So if you want to look at it and just sort of see, you know, how is my training, how is my scoring going up or down, you will get this out of your model as well. Cool, so I'm gonna let Leah take over and we're gonna discuss some things to watch out for.
Yeah, sure. So the first thing, we're going to talk about 2 things. The first one is overfitting. So what this might look like is like, let's say you spend all this time compiling a training data set and then you train your model and all it's spitting out are images that look pretty much exactly like images that you gave it already. And so overfitting is essentially when your model has memorized parts of your training data exactly. Yeah, so here's a like graphical illustration of overfitting and also its opposite, underfitting. What underfitting is when you have like your data set of like your X's and your circles and your model has kind of oversimplified the distribution of the data. So in this example, like the model might think, okay, the set of circles and X's is separable by a line when it's actually an oversimplification. And on the other hand, overfitting is a problem where your model has a lot of, it's a very like powerful model, has a lot of complexity and ability to capture a lot of data. And what that means is it might actually like force fit itself to little nuances in your specific instance of your training data set and not generalize very well. It might not capture the underlying distribution of your data set. Whereas in the middle, that's like happy medium, where it kind of fits, but is not memorizing your specific examples exactly.
Yeah, and just to add, I've never seen a StyleGAN model underfit. I don't even know what that would look like. So mostly you want to worry about overfitting.
Yeah. Oh, and I'll let Derek talk about these.
Okay, cool. So Yeah, so this is I'm just gonna pause this a little bit. So one way to tell if your model is overfitting is if you spit out a video of the interpolation space. So see how here on the right, it's like really seamless and it's really like clean, how it trains. If you compare that to this model, which is, see how it just jumps? There's like no interpolation between things. It just jumps around. That's a good sign that something is overfitting. And I think the next example is this. So this is like your fakes file. Now this is on a 256 model, so it's very, very small. But if you see here, like if you just look at this grid, you can see some images that look almost exactly the same, right? So this one looks like almost exactly the same as this one. This TV looks almost exactly the same as this TV. Now, when you're fakes, you should see some like differences in your images. So overfitting will generally look like, there's two ways to tell overfitting. One is in just looking at your fakes. If you see like the exact same image pop up in like 3 or 4 places, that's a good sign you're overfitting. And then if you want to make an animation of it, that will also help you see if you're overfitting. You'll see there's a little bit of variation, but not much. And obviously this is super pixely because it's 256 by 256. So I'll just add that like overfitting isn't terrible for art. It can produce really cool images, right? Like maybe you like the look of these images. The problem with it is kind of a waste of your money. Like you're spending a lot of money to make a model that is basically like looking like a crappier version of the data set you're trained it on. Now, maybe you like that look and maybe it's like totally worth it for you, but for most people, I would not recommend doing it. So just be aware of those cases where, you know, just think about like what you're actually trying to produce and make sure you're not like spending hundreds of dollars on something that is kind of trivial in terms of its output.
Yeah, so some causes of why overfitting might occur. Just a side note, I know that GANs in general, like as a model outside of the context of art, do not tend to overfit, but in this specific example where we are compiling our own data sets and like hand like scraping things and cleaning them, we're more prone to overfitting because our data sets are generally smaller. They might not be diverse enough and they might contain a lot of duplicates, which might mean to your model, which is capable of capturing a lot of complexity, it might see this small data set and over-index on specific examples that are in it.
Yeah, and so this is why people always ask me like, can I go lower with the number of images in my data set? And I'm always like, I really don't want you to. This is why. So realistically, like you can get away with smaller amounts of data in a StyleGAN model. Like I have seen people get away with 50 or 250 images, but like the risk is very, very high that you will overfit. And this is why for everyone's first time, I generally say like, please don't. Like try to hit 1,000. Like realistically, 1,000 is a good size data set. You can go lower, but you have the lower you go, the more likely you are to overfit. So this is why I am generally like, please try to find 1,000 images. Please try to find 1,000 images. It's because of overfitting. And I basically like, especially in this class, I don't want people spending $100 training a model to only have it overfit. So I try to push for people, at least in your first example, to like go higher in terms of data. And then, so you do have some options here around how to work with this. So obviously the number one solution that I would recommend everyone try to do if you do overfit is to add more images to your data set. That could be even finding some stuff that's a little bit more diverse than you would like. That can just help, if anything, it can help with overfitting. So there's also a case of where like, if you add additional images to your data set that you don't necessarily want to produce, it can basically like, once you have your latent space, you could avoid those images again, but it might actually help everything train overall. Second is you could potentially augment your data set. I've seen some people say that if you do slight crops like around your images, so say you have a 1024 by 1024, but you have it at a high resolution, say you have it at 1600 by 1600, if you do 1024 crops of those shapes around it, that's supposedly gonna help a little bit. Again, all of this is like sort of maybes. Like if you have a 250 image data set and then you augment it slightly and you get to 500, that doesn't necessarily mean it's going to work any better. It's just like, these are techniques you could try to use to see if it helps. And then we could also look at upping your gamma. So gamma could potentially help. It might also just make your outputs a little bit fuzzier and messier, but these are options to try.
On that note, Ted had a question about image diversity. Do you want to ask it?
Yeah, I just wanted to know if you could speak a little bit more about that. Like when is our training set too diverse, and how do we know if it's not diverse enough, kind of thing? Is there a way to actually measure it?
Oh, that's interesting. I haven't seen anyone doing anything around measuring, but that'd be interesting to think about. So I generally think if your image, your stuff is not diverse enough, if it basically looks like the exact same thing. So cases like that are, I would say video. Like video is a good example of where you might actually overfit if your video isn't different enough, right? So like you do need some differentiation. So some people might say like, what if I just produced a video of someone smiling and like not smiling and like just use that as my data set? Well, one, you might not have enough images just like from a purely like directional standpoint, but two, there might not be enough change where it might just learn just to re-smile, right? So a lot of it is just like, it's actually very guess and check. And like, if you have a data set and you're interested, like I'm happy to talk about diversity. On the other side, too diverse is actually harder to figure out. And like, what I would say is that, as I've been talking about that onion skinning effect, where if you were to layer them over top of each other, how different are the layers is a good way to describe it. If it's like you see some similarities between images to images, like, so for example, in my flower data sets where it's like, sometimes the branches match up and sometimes they don't, that's a good example of like good diversity. If I were to just take a random assortment of zoo images where like, here's a polar bear, here's a bear, and they're in different locations and there's different crops, like that's possibly too much diversity and that's gonna get really messy. Now with a thing like diversity, you might be able to get away with using attention to actually fix some of that, but it's unclear. One of the things that I'm really interested in is like, and this is the thing that actually people talk about a lot with GANs, is that no one is actually trying GANs with a huge amount of image data sets. Like this class here is probably going to try with a wider diversity of image data sets than like most researchers ever have. So like we are essentially like the guinea pigs for what is diversity and what is not. So it's kind of hard to say. We should just try it and see what happens.
Oh, and also to say one more thing about overfitting. I think last class, Derek mentioned projection and why projection was kind of developed in the first place. And it's a way to test if you're overfitting or not. One thing you can do is you can input an exact image from your training data set and then run the projection and then see if your model spits out like pretty much something that looks exactly like that. And if it looks really, really close, then that means that your model is very, very, very strongly capturing that exact image from your training data set. Whereas like if you input an image from your training data set and it gets something like a little more different from it, then that is a sign that overfitting is not occurring. Okay, and the second problem that you might run into is mode collapse. Mode collapse is actually a problem that everyone who uses GANs in general encounters. It's actually a problem with how GANs are set up kind of structurally and fundamentally in how they're trained. What this might look like when you encounter it is if you, let's say you go make a data set containing cats and dogs and you train it and then your model only spits out images of dogs and does not capture all of the cats that you put in your training data set. So generally mode collapse is when your generator finds a couple of solutions that fool the discriminator, but it doesn't capture all the other solutions that could also fool your discriminator. So here's like a little graphical illustration of what mode collapse might look like on the left. So in this case, your red dots are like your real data. And you have like 8 different modes in your real data. Maybe it's like cats, dogs, and hamsters and so on. But your generated data is only in one spot. So maybe you're only generating dogs, whereas the image on the right is more ideal. So this, I'm gonna go into a little foray of like why this actually happens in terms of like how GANs are set up. You probably don't need to know this, but it's just a little interesting tidbit of how stuff works under the hood. It's due to the fact that inside your GAN, you have 2 networks that are kind of fighting against each other. There's your generator and your discriminator. And the way they're trained is one is held constant while the other is trained. And then the other one is held constant while the next one is trained. And that's one entire like training iteration step. And what this means is it leads to very short-sighted decisions on each other's part because the generator is like, okay, the discriminator at this moment in time is doing this, so this is my optimal decision in this particular step. And yeah, I'll walk you through a little example now. So let's say you compile a training data set of like cats, dogs, horses, and birds. And your generator is like kind of like working and getting better at generating these images. And at some point, your generator gets really good at generating images of horses. And what this means in terms of the discriminator is that your discriminator is getting fooled a lot by images of horses. It gets an image of a horse and it's like, I don't know whether this is real or fake. So then in this step, your generator is generating images of horses. And then in the next step, it will be the discriminator's turn to make its optimal decision. So now with the generator held constant, your horse generating generator, your discriminator is like, okay, I know that the generator is only generating images of horses and I'm getting like consistently fooled by horses. So my optimal decision right now is to just say all horses are fake because I know I'm not good at all at detecting whether horses are real or fake. And then in the next step, where the discriminator is held constant and your discriminator is just rejecting all images of horses, now your generator is like, okay, I know if I generate horses, they'll be rejected by the discriminator. So maybe I'll get better at generating images of other modes, such as the cat. And then this might happen again, where the generator gets really good at generating images of cats. The discriminator is like, oh, I'm really bad at detecting cats. I'm gonna say all cats are fake. And then what might happen in later loops is your generator might just hop between two modes, between like the horse and the cat, and get kind of like stuck in this local minimum and not capture at all the dogs or the birds.
Yeah, that's a great description. And for me with StyleGAN, what it actually ends up producing is like these crazy, blobby, noisy images. So I think within classifiers, you will generally get a lot more of like, it says every horse is fake. In StyleGAN, you definitely get these like just weird images. So again, I think part of it is that it's this particular image is constantly tricking the discriminator, and it just like the generator just goes crazy at producing more of them. So this happens, this happens about 20% of the time to me. And we'll talk a little bit about how to fix it, but like, don't be shocked if you like are looking through your fakes and they're going, well, and then like within 2 or 3 ticks, you end up in this place where you just have full on noise. This actually happened to me earlier, like this week with a GCP model. It just generally happens, and it happens because of the stuff that Leah mentioned, which is that like at some point the generator realizes it can trick the discriminator, and then it just starts producing more and more of these files. It happens very, very quickly, which is always the thing that shocks me the most, is that like, it's not like it happens over the time span of a day. It happens over the time span of like 3 or 4 ticks. So in a couple hours, you can end up in a mode collapse. This is sort of what it looks like in your fakes, where you will see just like generally like these images are all looking like, one, it just doesn't look like your data set at all. Like, that's sort of the most interesting part. It's not even like it's overfitting in a sense that it's just only producing the same image over and over again. It's almost that it just doesn't look like anything. It's cool, like it's interesting images, but it just doesn't produce anything that's of that like interesting. And here's what the latent space like animation looks like. So again, you'll see it like, it looks like it's overfitting, but it's clearly not like overfitting to these images. Again, this is a really common thing. It happens quite often in GANs. And there are ways to fix it. So let's talk a little bit about how to fix it. So some options for fixing it are basically like, so again, as you're looking through your fakes or your ticks, find a fake that produced a good image that has a pickle file related to it. So let's say it's version 11,323. If that's the one where it's still producing good images, you can restart your training from that pickle file. So using that resume pickle and resume K image, you can go backwards, stop your training, pick up an old pickle file and restart. Now, sometimes it just will randomly work. If you keep all of your other parameters the same, it will just like learn differently. And again, it's because of a little bit of this randomness that's involved in training that sometimes a generator will just generate a new image that is not, that doesn't get caught in this local minima of the discriminator, like thinking that it's always working. Sometimes just restarting is all you need. I also generally recommend that you might want to start one pickle back from where you would even start before then. there is a chance where your images are already sliding into mode collapse, but you can't tell yet. So in general, I would say like go back one more pickle. So if like 11.323 is the latest fake that has a pickle file that you think is good, you could go to whatever is the one prior to that and train from there. That's generally just like a slightly safer bet. Now there are other things you could do on top of that. So the next is you can have your learning rate. So if your learning rate is like 0.003, you can cut it in half. The reason why we think this works is that it, again, learning rates are like kind of a, you have to learn a lot about how the learning rate works. But if you imagine that like a slope for your gradient descent, it's just going to train a little bit slower, and it might not jump around as much, and it might not get caught in the local minima. So the alternative that people have recommended is also to cut your generator learning rate by a lot. So actually cut it by a third, and then only cut your discriminator learning rate by a little bit. This again gets to the point of what Leah was discussing, which is like, this is how you can keep the discriminator like a little bit smarter than your generator. One thing to note with this is that if you do change this, your training will take longer, right? Because you've made your learning rate slower. So while I wouldn't say like, some people might see this and be like, well, why don't I just start my learning rate at 0.001? It will just take you like way longer to train your machine. So in general, I don't recommend doing this unless you've actually hit a mode collapse. So starting with the learning rate that we already have, just use that as a default. If you run into a mode collapse, like let's talk about it, and we can sort of decide to change our learning rate or do some other things. Another option you could do is double your mini batch size. So there's a lot of research out there that says your mini batch size is actually probably more important than your learning rate. And there's lots of reasons we can go into about that. But if you can make your mini batch size larger, you should try. In most cases on our 16 gigabyte GPUs, we might not be able to do that, but we can try it. So I think the default mini batch is 32. So you could try upping it to 64, but keep your GPU mini batch the same size and see if that works. Now, the real thing would just be to do all three and just see how that works. But in general, you could play with any of these things. So you might actually want to play with only doubling your mini batch size and restarting from a new pickle and keeping your learning rate, because that might actually like train stuff faster while also seeing if you can hit a mode collapse. Now again, mode collapses happen pretty quickly and they are like a little bit random. So I wouldn't like throw out an entire model just because you hit a mode collapse. It's probably like overfitting is very clearly due to a data set problem, whereas mode collapse is just sort of a randomness thing that sometimes just happens to all models and you have to sort of work around them. Any questions about mode collapse or overfitting? Okay. Obviously, if you run into those, talk to Leah and I, and we can help sort of assess how to go forward. So I want to talk just really briefly before we go to homework. I know we're a little over time and I apologize. I want to talk about how to decide which iteration is best. So I see also a lot of people who will like look at their individual fake files and they will say, oh, I really love the fake images produced by 10474 and not the ones produced by 10470. And that is not how I would assess your images. So let me skip ahead here really quickly and go back to how I would assess your images. So my personal feeling is that, let's say this is 10216 for your training. My personal feeling is jump every 100K images and assess on those levels. So don't look at the fakes next to each other because that's like the slightest moderation and change. Do big jumps. So this is 10216. Let's say this is 10416 and this is 10616. Now, because this is so early, I could sort of obviously say like, oh, well, the later it trains, the better it's going to be. But it's also dependent on what you want to make, right? So like in this case, you'll see that these images are very, very blobby. You have these like very interesting sort of grid-like effects. So if you want to produce something that looks like this, like take it by all means. But don't try to assess this one versus the next tick because like you'll just be kind of driving yourself crazy by trying to, it's like tasting your food to see if it's finished like every 10 seconds, right? It's like, no, you want to stop, like you want to taste food every 5 minutes or every couple minutes, like clearly shouldn't be like testing it every second. That's how I best describe it. The next thing is just to really like remember that like this is just a sample of the images produced, but you can produce millions upon millions of images. So just because I like this one image does not mean that the entire data set is good. It just means I like this one image and maybe I should just download this one image and crop it and like share this. So realistically think about like how you have a wide range of images that you might want to play with. So here again, this is a case of where I might not recommend deleting all your pickles just because you only like one fake file. You might want to download, say, like pickle files that are 100 or 200 ticks apart. Download those and quickly bring them into Colab and train some iterations just to see what you get out of it. Again, the further apart they are, the more likely they are to be very different, which is why we want to train these for a couple days instead of like 30 minutes or like a couple hours and then just like grab whatever we get. So, you know, it's really, I see a lot of people who are just like, oh, well, I like this one image or I like this set of images and like, this is the right model, right? And it's like, maybe, maybe not. I would generally like give yourself more time, train for longer than less time because you can always go backwards. As long as you don't delete those pickle files, you can always go backwards if you feel like it trains too long. And I think someone either in this class or in a previous class asked, can you train for too long? And the answer is yes, you can, but it's like a personal decision, right? So again, if I really want images where they're really blobby and look less and less like flowers, but still that flower texture, this might be the good version for me. Whereas if I really want to go toward realism, I might want to train further and further and further and see what happens. So really like, this is where the artist's eye becomes like the big thing here, right? It's really what do you see and what do you want to learn or what do you want to get out of your models? So you probably can't train for too long on StyleGAN, although basically what I've seen is that you get diminishing returns, right? So it's sort of like for the first couple of days, you will see a huge exponential change in your model. And then the later and later it goes, you'll see very, very, very slow increments for updates. But it is important because I've actually seen, so I actually had a student in January who trained one of his models for 2 or 3 weeks. And he showed me at day 3 or 4, what we all thought was a really, really good model. And then he showed it to me again at week 3. And it was like a huge improvement between those moments, right? But again, if he had just looked at it at day 6, day 7, day 8, day 9, and just compared A to B, it might not actually feel like an improvement. But when you saw that big leap, you really saw that it did learn a lot from there. And in general, what I've learned is that the longer you train a model for, the better it is at learning new textures and the better learning is at sort of like color representations together. So in general, if you want to train a model for 4 weeks, like you will get really good results. But most of us are antsy and we want to quickly play with stuff beforehand. So you can always download a pickle file and play with it in Colab before you get too far down the road. And because it does cost a lot, some of us will want to turn stuff off earlier than later. And that's totally reasonable. Okay, so assignments for this week are to finish your data set. If you haven't started a data set or anything, like let us know. If you have ideas on how to get data, like but aren't sure how to do it, like let Leah or I know, and we might have some recommendations. I will say, for this class, if you don't want to make your own data set or you don't want to even create a data set, let me know. Like I have plenty of backlog data sets if people want to train stuff. If people just want to run the commands of training and not want to make a data set, let me or Leah know. We have plenty of data that you can work with. And then lastly, like it would be good to start training this week. So we've got like 2 or 3 weeks left of the class. The video for training on GCP is up, and minus a couple little issues. Actually, I haven't heard any issues about that video. If you do run into issues with that video or like something isn't clear, let me know. I'm happy to add detail to that or make a new video that explains stuff better. And I would say just as a reminder, do keep an eye on your training every couple hours. I have had some hiccups on GCP recently where GCP like restarted my machine and I checked it like 6 hours later and caught it. But if I hadn't checked it immediately, like I would have lost some training time. So do check every couple hours, every 6 to 12 hours, I would say, just to keep an eye on it. Plus it's fun. You start to see it training and you get like really excited, and then you're going to try to check it every hour and it's not going to be as fun. So, you know, put in a little bit of hesitancy there to like tell yourself, okay, I checked an hour ago. I need to wait a little bit longer. It's like baking. So much of it is like baking. Yeah. So that's it for this class. Again, I'm happy to stick around for like 30 minutes if you have questions or if people want to talk about data sets. But if you do need to take off, and I totally understand. So at that point, hang out in Slack if you have questions about stuff. I'm happy to answer questions in Slack. If you're into issues with either training or getting set up on GCP, let Leah or I know, and we're happy to help diagnose things. Does anyone have questions that they want to talk about? Kynan, go for it.
What are your non-square data set or PKL that you've already trained? What are they based on? Are they like fast flicker and stuff like that, or what have you got? I'm curious.
Yeah, so I mostly have like my floral data sets, and I've got some video, like some noisy, weird videos they've been training at. So basically, if you rip a DVD, I think a DVD is like 720 by 640 or something. So I've got some data sets of just like video that I ripped.
Oh, cool.
That are like at smaller sizes. If you're ripping from a DVD, you really can't get very high resolution. It's like 480p or something. It's like pretty ridiculous. But I do have some models like that as well. And again, it doesn't actually matter what you train from. It's like, it saves you time no matter what. So like, just train from it. Yeah, but I do have some examples of like florals and other things. I could probably set up like a quick page of just like all the different data sets or training models I have if people want to see that.
Cool. And my other question was, with these videos that I have, would it be better to keep the variation of all the files? Or would it better for me to go in and like track around the eyes so that they're all exactly in the same spot? Like, I'm not really sure what would be better, or would they have the same results in the end anyway after enough training?
That is a great question. So Alana has like so she posted her birds in the StyleGAN channel, maybe like at the beginning of class. And I think what was really great about her example was she had the birds were always very centralized in the model. So what you get when you train it is that you get this like really cool effect of where the birds are always centralized. I realize I'm like doing this to my face and you guys can't see it. So it's always centralized, and then like the environment is shifting around it. So that's like the thing is like, if your onion skin is overlaid so that the eyes are perfectly lined up, everything will change around the eyes, but the eyes will generally stay pretty consistent. So again, it's just sort of what effect you want, right? So I'd say like, if you can align stuff and you want something to where it's like the change rotates sort of around that singular locked position, it's cool. It's definitely like an interesting look. But it's also just up to you. It's like, you could also shift things a little bit, and then you would also get the eyes to sort of shift in directions or like other things to change. That's what's really cool about this stuff is like little changes like that can have a dramatic effect on like the output. But until you sit down and play with it and train 2 or 3 different models, you don't know that. And that's where it's like, it's kind of annoying because you have to like sit there and like wait for a week, wait for another week, and then compare the two. But yeah, there's lots of different variations on your data set you can train to make slightly different modifications. And it's still really, really cool to see lots of stuff like that happen. Kyle. I can't hear you. You're not muted, but I can't hear you.
Sorry, I think
okay,
I had
there you go.
Okay, sorry about that.
Nice.
I think you might have answered this, but so one of the things I want to do is these pictures of a specific style of home in Hawaii, and I don't even know if there's if there even exists 1,000 of them. And you're saying that you really just want to use image augmentation or the flipping as a sort of like a last resort to see if it'll fix it. But is that, I mean, I guess my question is 500 images going to be enough if I do image augmentation? I just do horizontal flipping.
Yeah, so if you have 500 images, I would say there's a couple of things you can do. One is definitely augmentation works, but I would also look into doing this like slight cropping technique where basically you take an image that is slightly larger and then you crop some panels out of it. That I've seen has like, it generates a little bit of a different effect, but it does help with overfitting a little bit. So sort of what I was talking about with Kynan, where it's like, if the things perfectly align, like you get this really cool effect. But for things like houses or other things where it's like they're slightly shifted a little bit, it's going to be fine because it's going to like change the lineup a little bit. But it's definitely better than overfitting. Like it's basically like everything is better than overfitting. So like overfitting is the worst thing that could happen to you. So any technique you can use to like reduce overfitting or the potential of overfitting is going to be the best thing you can do.
Okay, thank you.
Go for it, Martin. Yeah.
This is probably not the one I'm going to do for this project, but I have another data set from, it's a national library, it's this library project, and they have images of the fourth rail bridge. It's a really famous rail bridge in Scotland, but they have images of like illustrations of its as it was being built. But that data set is really small. It's like 120, and I was thinking, I don't know if this is going to work, but I had an idea to maybe get around that, which was to like, if I could scrape images of the bridge from Instagram, train a full model on that, and then just right at the end, like just retrain for like, just with the 120 images for like, I don't know, just to, like for the last part, just to get the stylistic traits of those images.
Yeah.
I don't know if that would work.
Yeah, I honestly don't know enough about, like, this is, again, like, the funny thing is this class is basically a research facility. Like, we actually, like, people don't know what works or what doesn't. So a lot of the techniques that we're going to try in this class, like, might work, and it'll be cool. And, like, we should, if you find a technique that works, you should publish it, because people will be really excited about this stuff. Because there's, like, a community of people who are also doing work sort of in different areas of StyleGAN, and, like, things like this, if that works, like, that is a thing that people want to know about. So, like, we should try it and just sort of see. I mean, if you only train it for 10 ticks, it's like, that's gonna be what, like 10 hours. So, like, it's $10 to try it. And if it doesn't work, then you know it doesn't work. And if it does, then it's great. So, yeah, a lot of this stuff is just like, we're gonna try some things. We're gonna see what happens. So for example, like, I used to teach this class, and I used to say, like, only 1,000 images. 1,000 images was my threshold. And people kept challenging me, and I was like, fine, all right, I'll find a data set that is 500 images, and I'll try it, and we'll see how it works. And to be quite honest, it is working. It's actually still training, because I cranked the learning rate down, because I kept getting mode collapses. So, like, it does work. You can go lower, but it gets just messier the lower you get. Go for it, yeah.
That's the question, totally different thing. You mentioned in the use raw parameter, and you said there's a difference between, like, the StyleGAN2 TF records and then the new one. So so there isn't, between the StyleGAN1 and StyleGAN2, there is not a difference in TF records. In the particular Skyflynil fork that I sort of am showing, there is a difference in how it builds the TF records files there. Now, again, I would personally just say, like, just upload your raw data set again and retrain it, or rebuild the TF records from using that. There's a technique of create from images _ raw that creates a different TF records. I would probably recommend just doing that. If you don't have the original data set, then you can still use the other TF records format. And we just need to make a couple changes to the training parameters to make that happen. Okay, cool.
Yeah.
Thanks.
Esteban.
On the video you sent yesterday, you're showing how to train a non-square model.
Mm-hmm.
Can I use the same video to train a square model? It would be the same thing?
Yep.
Same settings?
Yeah, so you can use the exact same settings. And I would actually recommend doing that, because that Skyflynil fork has some interesting new parameters to play with. All you'll want to do is, when you use the min H and min W, you want to make sure that the math adds up to whatever your dimensions are. So if you're doing a 1024 by 1024 square, you'll want to use reslog 8 and then min H 4 and min W 4. So if you have questions, just, like, DM me. I know we can work with that to make sure you're set up before you start training. Yeah, go for it.
And I have ready 2 data sets. Maybe I already show you some of them. So it would be okay to train first the color one, and then wait, like, maybe 1 week or a little bit longer to train the second one? Yeah. Or can I train both of them at the same time? Or impossible?
Well, you can't train both of them on the same time on the same server. You could set up 2 servers. You might also want, since I know you really love to train stuff, you might also want to look at that collab training and try training on collab. In part just because, like, you will quickly burn through GCP credits. Like, again, you really only have about 10 days of total credits to train on GCP before it gets really expensive. So you might want to look at the collab stuff, that collab notebook I have. You know, it's like, it's just a balance of, like, how much money do you want to spend versus how much time do you want to spend? And if you can, yeah, exactly, right. So if you want to spend more time, but it's free, then you might want to look at collab. It'll work. It's just a little bit more annoying. You have to, like, every 12 hours, you have to, like, reset your machine, but it'll work. Adam, I think you had a question? I cannot hear you. Nope. Do you want to just post your question in the chat, and I can just read it from there? Okay, cool. While he posts that question, does anyone else have questions? Yeah, go for it, Martin.
Yeah, just about, you mentioned you have some resources for converting video to, you know, creating the data set out of video.
Mm-hmm.
Are those just in your GitHub? Can we find them on there, or is it somewhere else?
Let me just make a note to add some video for that. So basically, like, there's a thing you need to do, which is just like, which I actually do not have a video about, and I should, which is like basically you need to use FFmpeg to basically whenever you get your video downloaded, you need to use FFmpeg to split your video into frames. And then once you have the frames, then you're basically just going to use like the datasets tool library or something else to like massage them into the format you want. So one thing that I think is really important about video is that you want to make sure your frame rate isn't too high. It's very easy to just spit out 24 frames per second of a video, and then you end up with 30,000 frames of a data set. And in my experience, that is like, it's gonna take too long to train that. So like, I usually find that like 2 to 4 frames per second gives you a nice diversity without having like every single little shift in a video. So I just recommend like playing with like those sort of techniques. There's also a tool in the dataset tools library that I think, Emily, maybe you were using, which is called dedupe, which helps remove very similar or duplicate images. In the case of video, if you're like pulling from a random video source, you don't know what they actually built what the FPS is on the actual video, especially if it gets uploaded to YouTube. Like YouTube might like crank up the FPS or whatever. So using that dedupe, it's a very slow process, but it helps remove duplicates from your files, which is good for dataset training.
Can I just clarify one thing?
Yeah.
Do you drop the frame rate of the video itself, the video file itself, or can you like select the frame rate in FFmpeg?
Yeah, FFmpeg allows you to set a frame per second. So you would set it there. Yeah. So I'll probably record a video this week of doing that because many people have asked me about this and I just haven't recorded it. So I'll do that this week just so people have it. But yeah, that way it's a resource that everybody can use. But yeah, FFmpeg has some really cool features that allow you to do stuff like cropping or other things. So if you are interested in that, FFmpeg is like, I could teach a whole class on FFmpeg and it would take like 10 weeks. It's like an insane library. But there's some really cool features in there and it's really easy to just rip video into individual frames using it. Adam, so you asked, can you add new images to an existing pickle file? So you can't add new images to an existing pickle file. You could, if you have that data set that it was trained on, you could add new images to your data set and then train on that sort of augmented data set. Does that make sense? Sorry, we're just like, now I can hear you. Go for it. Yeah,
okay.
I can.
Great. So, but then are you, like, if you still have the same data set, then are you starting training from the beginning, or how's that work? Like,
no, I mean, so basically the way that transfer learning works is it takes the model it already has and it starts to train it with the discriminator again. So if you have images, so basically like, let's say you have images of dogs that are all Labradors and you want to add some pit bulls into that mix. Like the model is already trained on doing Labradors and the discriminator will see some Labradors and then we'll see some of them see pit bulls. And when it sees Labradors, it'll say, yep, this looks pretty good. And then when it sees like a pit bull, but it's seeing the generator is producing a Labrador, it'll say, wait, this doesn't work. What's going on here? So the generator will learn to add that additional data into its mix as it begins to produce new images. So you're not really training from scratch, and like you're never training from scratch when you do transfer learning. You're always saying, hey, take the stuff you already know and then either add or change what you know to match this new data set.
So yeah. Are you transferring learning then from your previous pickle file like
yes.
that? Yeah.
Yep.
So, but that would be like unless you had all the same setup on your server, that's probably like a complicated setup to do, right?
Not necessarily. So the pickle file just contains weights. It doesn't really contain architectures. So if you're just like moving it over, like basically if you just were to like, especially in Colab where like sometimes you might just have the same repo in your Google Drive or whatever, you could always just move that pickle file over. And as long as the resolutions match in your data set and in the pickle, it doesn't matter. Like, you know, I would generally recommend that you use the same repo. Like if you're going to use the Skyflynil repo, like always use that because there might be some architecture stuff in there that if you change it, it might get messy. But in general, it's not as hard as I initially would expect. Or like, I think it's like the first time you do it, you're a little scared that's not going to work. And then you do it and you're like, okay, this works fine. And then you sort of learn that it's like, it's not as hard as it sounds. But that first time is scary because you're like, what if I'm spending 3 hours and this is a mess? Like, but yeah, it generally works okay. Yeah.
So if I took your collab training video and then tried to just adjust it and use one of my existing files as the like the one that's transfer learning from, and then add all the same images from that same one, but along with my other ones that I've now added, and then start the training from there, that would be sort of a way to start.
Yep. Yeah. And I mean, realistically, like your training will probably not take too long. Like literally in a day or two, you will definitely see like the results of your new training in there. Maybe even less. I mean, it might take 8 hours to do that work because you're essentially like, you're just adding new data to the model that it needs to know about. Now, one thing that's worth noting is that your model will not be the same because it will be dropping certain features, right? Like it will be removing certain things it learns because there's a set number of features it can learn. So it's going to be deciding what it drops in order to pick up new things. So sometimes like you might actually lose some details you liked from that model to get other details in your new model, if that makes sense. So it's always worth to keep that old pickle file because you might just be like, there's some good stuff in here that is no longer in the new one. That's the one downside of doing this stuff. It's not cumulative. It's sort of like finding what it needs to replace and what it doesn't.
Cool.
Who else has questions? Moises, go for it.
So in terms of output, like if I'm working with more like flat images and like, is the output, if the images, let's say, are like, they don't get blurred, like I'm not making them any larger, like will they have fine edges, or like I'm assuming they'll still have some gradients between like the other colors coming in, or things like that. I guess when it's not so much about realism but shapes.
Esteban, would you mind in the Slack channel, whenever you get a chance, can you share the model you made last time in class? Because I think you have a really good example of where you had very flat shapes and it trained in the flat shapes, but then the output still had like some texture to it, right? So if you wouldn't mind like sharing both your—
But what do we want to see? Do we want to see the training?
Like what I would want to see is, can you show just a couple images of what your data set is and then what the output video was? Because I think, so to Moises, to your point, like it will never be, this gets into like convolutions and what these networks are meant to see. If you upload very flat things, it will add some texture and dimension to it because it's basically, it's trying to find photos or trying to find textures that don't exist in the model. There's also like, in interpolation, it's finding midpoints, which means gradients might exist because it's changing colors or other things. Yeah, it's very interesting. Like actually so I read a really interesting research paper this week that's basically like, what's all the stuff we don't know about GANs? And I would say like half of the stuff that he's asking about is stuff that we're trying in this class and are things that I think like are really, really interesting because no one else in the GAN community is trying it. And that is like flat vector shapes put into a GAN do not produce flat vector shapes because they are like kind of not trained to do it. So the joke I've made in previous classes, like GANs are all meant to find zebras. They're looking for zebras in their model because they're looking for these textures. And even if you don't provide it that texture, it's going to find it. Or like kind of like find a way to find something close to it. So it's really interesting like that vector shapes like kind of work, but also don't at all. I think someone else had their hand up and I missed it. Esteban, you had your hand up earlier, right? You're still muted. Hold on, let me see if I can unmute you. Nope, I can't unmute. There you go.
Yeah, I'm finding the file. I'll get back to you in a minute.
That's fine. Yeah, you can also wait. I mean, it's not like a rush, but I think it'd be interesting because you did some work that I think is related to what Moises was talking about. Yeah.
Yeah, if you could share that paper about what we don't know about GANs too, I'm super curious.
Yep, definitely. I might have posted it in the paper channel, but I will definitely add it here as well.
I actually found this really interesting data set that it's at some research facility in Turkey, and they were asking me what research institute I worked for, and I need a like a research research approval. So I mean, I let them know what we're doing, and we'll see what happens. But
yeah, there are lots of data sets where they're like they won't give it to the public unless you like work at a school or whatever it is. I happen to have an edu address from a I taught like as an adjunct for a while, so I use that, and usually that's enough, but it depends. Yeah. Anyone want to talk about maybe what they're interested in producing or have questions about, you know, how to go about producing stuff? I will say for this class, I've generally like sort of like let you do your own thing with data sets, but if you are really interested in like producing data sets, I do have that whole list of videos, but if some of those are confusing, like I'm happy to talk to people about how we can go about producing stuff, because there are ways, if you never use like Python on your local computer, it's kind of a disaster. But there are ways to like scrape images using like Chrome extensions and other things. So if you want to look at stuff like that, let me know and I can also link you to some resources. So I'm teaching a runway class on Tuesdays. Lee and I are teaching that together. And they are like, they have no coding knowledge. So like for a lot of them, they have no idea how to scrape images. So we are looking at stuff like Chrome extensions for them. So hopefully that will also help this class if you're interested in that.
On that, there's one for Pinterest called Pin Down, which is pretty good. Which
Cool.
is like one click and it's done.
If you have a link to that, can you post it in the Slack? I think that'd be really helpful.
Yeah, sure.
Cool, awesome.
Oh, and Adam, if you post those projection experiments you had, they sounded really interesting.
Yeah. I'm gonna make a note for myself to also do, I'll do a video about using projection in Runway. In part because I think my Runway students will like it, but it also might help you guys as well. One of the things that's tricky about projection is that you do have to feed it the exact same resolution image. So basically if you upload like a 800 by 800 image, it doesn't like automatically do the math for you to like upscale it. So it can be a little finicky. So that's one thing to know, is that a lot of these models are like really finicky about what they take as inputs. So you have to be very, very careful and clear about that. Esteban, do you want to ask you have a question now? Hold on one second. Let me unmute you. Go for it.
Can you hear me?
Yep.
I already uploaded a file
Okay.
on the Slack channel.
Great, thanks.
And also I'm pasting a video, a link for the video that I'm doing now.
Cool.
And my question was that, I forgot my question, sorry.
Sorry about that. I gave you a task and then I made you forget your question, sorry.
Yeah, no, my question was that if I have to train this new model using my previous model, will I get some kind of styles out of the first model when I'm training the second model? Or I will get like a real different new model based on the new images that I created? Because the new images that I created have white background, and the images that I use on the first model, as you know, they have a lot of colors and background colors. They're full bleed.
Yeah. So in my experience, for those first couple ticks where it's just like, so for the first couple hours, it will look like a mix of your two data sets, right? So it's that mixed model training. Within 6 to 8 hours, if your data set is very different from your current model or your previous transfer learned model, it will eliminate all that. So like in your case, like I would expect the first couple hours, you'll get sort of a mashup of different things because you have all these flat shapes that are sort of similar. But I would say within 8 hours or so, like you will have all white backgrounds if all of your data set is white backgrounds. I've only learned this just from like purely experimenting, but like it does sort of eliminate it eliminates almost everything you see within the model like very quickly.
And the second data set that I created is totally different. I use, as you know, these weird textures from trees, from 500 pictures that I took from trees. So it would be a totally different thing. So it is okay to use my colorful data set to train that one, or should I use the pictures that you describe on the?
Yeah, it's up to you. You could use FFHQ or you could use your own model. Again, really the only thing that matters is that 6 to 8 hours of your initial training time. So like if you were to take, what you're saying is like, it's like wood bark, right? So if you were to take those textures and apply it to your flat vector files, the first couple hours, you're gonna see these weird mixes of like textures and flat vectors, which actually might be cool. I don't know, we could look at it. For the first couple hours, you'll see that. And then like very quickly afterward, it'll be completely gone and it'll just be textures. I know everyone is like, everyone is like very obsessed with like transfer learning, be like, what's the perfect model to transfer this from? And the answer is it doesn't matter. Like it really doesn't. Very quickly within like 8 hours, everything is gone. So like I wouldn't worry about it too much. But if you have these like very small, like those very small increments of like a couple hours where you do that mixed model training, that's like, if you want to see some really interesting results there, what you transfer from matters. Whether it's faces or whether it's your vectors or whether it's from other things. For a very short period of time, there's some really interesting, weird stuff. And there are people who like almost focus exclusively on making StyleGAN models using that weird window of time. And like people who are making lots of weird, strange models using that small little mixed model period of time.
If that's the case, how can I save more time?
How can you save? Oh, you mean like how can you save your pickles out during quicker?
No, how can I save more time training the new model? Like,
yeah, so that's a case of where it probably does matter what you're training from, but it matters in the sense of like 2 hours, 3 hours. Like if you train from your flat vectors versus the faces, there might be a 2 or 3 hour difference. So in the long run, it's not worth fretting about those things. And also, I honestly couldn't tell you. I would guess maybe the FFHQ would be better because it's photographic and you're transferring from photograph to photograph. That's like that's my gut, but like I can't tell you if that's true or not. So the truth is like it's not worth worrying about 2 hours of time in the grand scheme of StyleGAN models where it's like about weeks and months. It's not worth worrying about 2 hours of saving yourself time. Martin, I think you had a question.
Yeah, I was just going to ask if you know if doing mixed data sets from transfer learning, if that window is like collab time, like if you could do that in collab, if that's, but I guess it is because if it's like the first couple of hours, then it's totally possible. So if that's,
yeah, that is definitely collab time, and that is like a lot of people just do that in part because it's cheap. It's like free essentially, but it is totally within collab time that you could do that because it is 6 to 8 hours on a P100 or a V100. So it's definitely doable within time. So if you want to experiment with that and not lose GCP credits, I would definitely recommend doing it in collab and seeing what you get. All right, unless you have other questions, we can end it here. I have a laundry list of things that I owe people, which is great. I love that. That means I have work to do for the next couple days. So we'll obviously be recording that. We have recorded this video. I didn't screw up this time, so you have the full video, including the Q&A. Yes, thank you. This video will probably be done in a couple hours. I'll upload it. I'll add it to our class notes. Leah always takes notes. And I definitely recommend you read her notes. Her notes are like better than watching this video entirely. So there's lots of good notes in there. And then I've got a list of things to add to our class notes overall.
Yeah, the class notes are already linked on the class page for this class.
Cool. Yeah, so this will be great. Great. I have to run an errand, so I got to take off. Esteban, one more question. Then I
yeah, one more quick. Can I contact you, Leah, like anytime for questions or during the settings for the server? Is that okay?
Yeah, for sure. Yeah, you can just you can message me or Derek in Slack directly too. Anytime.
Yeah, so you guys are welcome to DM me or Leah. Maybe both of us, because it might be easier for both of us. That way we also know who's having a conversation with who. But yeah, it's really helpful to just let us know. You can also post in the Slack channel. There's a chance that especially around data sets, there's a chance that other people know more than I do or Leah does about certain data sets. So especially if there's things where you think like this class as a group might know more, please post there. And I also, if you ask me a question, I might just recommend you post it in the main Slack channel as well. There are also other channels in Slack. Like I have a data sets channel, I have a papers channel, I've got some other channels. You might want to even post there because there's people who are not in this class who are interested in those topics and might be able to recommend some things for you. So especially around data sets, there there are vast numbers of data sets out there in the world that I am not aware of. So definitely post about data sets or interest in where do I grab images. Like I saw someone the other day was asking in the data sets channel about how to get the UV images of a face map. So I don't know if you've seen these, but like it's basically like you take your face and you flatten it and then you have a UV map. Someone was asking like, where do I find all those? And other people have really great resources that I've never thought about. So try to use the community because there are people in that Slack channel who are very interested in helping or just like interested in seeing what other people are up to. Cool, okay, so I have to run, but thank you everybody, that's a really great class. And I will be adding new details and other things to our channel over the next day or two. So otherwise, I will see everyone next week. All right, bye everybody.
Bye everybody.